Okay, for safety occasion, it's better to wear mask, gloves, and also an apron. And lastly, wear a safety goggles. It is to make sure that there is no tiny particles will affect you. That's all.
Okay, the possible reason for discrepancies opting for the tested specimen is because of certain errors. For this case, it is the systematic errors, because the machine inaccuracy and random error, which is the error occurs in judgment of an observer when reading the scale of measuring device to the smallest division. The similarities in mechanical or material properties for the material tested is steel, brass, and aluminium. All of them have is ductile, and for the difference between them is steel have a high hardness, brass has a normal hardness, and aluminium is soft. Okay, between yield strength and yield point, the yield point is more accurate because it shows the point in the stress strain curve at which the curve levels of the plastic deformation begins to occur. And the yield strength is not accurate because the yield strength or yield stress is a material property, and the stress corresponding to the yield point at which the material begins to deform plastically. The more important indicator of a material mechanical behavior is elastic limit. It is the more important mechanical properties when compared to proportional limit because it shows how much stress can be applied at the material before it enters the plastic region. The proportional limit show the highest amount of stress that is directly proportional to the strain. It is the point on the stress-strain curve where the material starts to enter non-linear region of curve, the plastic deformation, which is the plastic deformation region. The advantage of stress-strain diagram over the load deformation diagram are we can identify the modulus of elasticity for the sample use. The slope of the load elongation curve will not be the same as the slope of the stress-strain curve. Stress is load divided by a constant area and strain is the elongation divided by another constant.
For the conclusion, from this experiment, we can obtain the mechanical properties of each sample. When the sample being stretched, it experiencing elastic and plastic deformation. The strain hardening phenomenon occurs when the sample is getting stretched until it goes fracture. We also achieve to obtain the mechanical properties of the modulus elasticity, the yield stress, the ultimate stress, the fracture stress, and the ductility ratio. By doing this experiment, I can understand that the different material and cross sections behave under an axial tensile loading. I can determine that the stress-strain relationship and compare the mechanical properties of various materials and cross sections.
I've